Okay, so when you enter this data into your graphing calculator, what you will be given will look like this. So in order to write the equation, you need to input A is your slope, and then B is your y-intercept. So this is the equation for the line of best fit. So now what we need to be able to do is we need to be able to interpret or say what it means. You need to be able to look at this equation and understand what it stands for in this problem. So to help you with that, what you want to look at is you want to look at what does the x and y stand for. So when I go back up to the problem, it says that the table shows the number of people, x, in a room and the temperature in the room, y. So it's saying that x represents the number of people and y represents the temperature. So when I look at my slope, so the slope is 0.7, and then to make it the fraction of y over x, 0.7 over 1. So 0.7 is my y change. So it's saying that the temperature is changing by 0.7 degrees, and it's positive, so that means it's increasing. So this means that the temperature is increasing by 0.7 degrees, and then this is a rate, so it has to be per or for every or for each. So it's 0.7 degrees per 1, which is x, and x represents people, so it's per 1 or per person. So then when we want to look at our y-intercept, it's important to remember that our y-intercept is a point. So it would be 0, 75.42. So the 0 is the x, which is the people. So when there's 0 people in the room, then y is our temperature. It was 75.42 degrees. So what that means is that at the beginning, it started at 75.42 degrees. So another important piece, so just like when we did residuals, our calculator figures out something similar, and it's called the correlation coefficient. So what the correlation coefficient tells us is how strong the correlation is. So it's kind of like a percentage where 1 is like 100% and 0 would be 0%. So the closer it is to 1, the closer it is to a strong positive correlation. So what that means is that it's almost a perfect straight line going up. The closer it is to -1, then that means it's a strong negative correlation. So it's almost a perfect straight line going down. And then the closer it is to 0, that means that there's no correlation. So then that would mean that our line of fit wouldn't be very good because the points are all scattered everywhere. So if it's closer to a strong correlation, then it's a good line of fit, or a strong negative correlation, that's also good. But if it's closer to 0, then that's not good. So when you enter the data from the temperature into the calculator, it's going to tell you that your R value is 0.96. So this is really close to 1. So this is a good, strong correlation. There's a second number called R squared. And R squared just tells you the accuracy. So again, it's similar. The closer to 1, the better. The closer to 0 is not good. So in this case, our R squared is 0.93. So this is a pretty accurate line. And then the last thing we're going to talk about is interpolation and extrapolation. So interpolation is when you're finding data within, or when you're predicting data within the data set. So if you look at the front page where we were talking about the pineapple plants, in the middle of our data there was a gap. We didn't have points for years 5 or 6. And so if we were to use our equation for our line of best fit to find how many pineapple plants there might have been in years 5 and 6, that would be interpolation. That's within our data. Extrapolation is when we're finding or interpreting or predicting data that's outside of the range of our data. So going back to the pineapple plants, if we were to try and predict in the future how many pineapple plants there would be in year 12, that would be extrapolation because that's outside of the data set. So we're going to look at this. So here we're going to approximate the temperature when there's 15 people in the room. So our data only goes up to 8 people in the room. So this would be extrapolation. We're finding what the temperature is outside of our data. So what I'm going to do is I'm going to use the equation that we found. So the y equals 0.7x plus 75.42 repeating. And I'm going to input 15 for people. So since x represents the number of people, I'm going to put 15 in for x. And then I'm going to go ahead and use a calculator to multiply this. So 0.7 times 15 is 10.5 plus the 75.42